Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now, what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now, by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end.